In this video, we are going to discuss about design thinking based development of combinational logic circuits. The combinational circuits are playing vital role in our digital electronic circuits because nowadays we are using more number of digital electronics in your home itself. So that it is an important factor to discuss all those combinational logic circuits in this video. Especially for combination circuits, we are using more number of devices for a single circuit, so that it is called as combination logic circuits. So in this video, we are going to discuss about how this combination circuit has been played in design thinking process. So in design thinking, we are having 5 stages: empathize, refine, ideate, prototyping, and testing. So these will be impact for combination circuits has been discussed. So let me see how these devices has been initiated for every stages.
So hi everyone. Today I'm going to say about the empathy part. Empathy part is nothing but we have to understand the user needs and challenges. So we are going to conduct the activities like we have to ask, we have to conduct the interviews like what are the queries you are facing and what are the challenges you are facing. Example, we have to conduct interviews with operators and lab technicians and students, and then. Uh, Key points like accuracy, speed, and testing. Example, we take designing an vote booth machine. In vote booth machine, we have to, first of all, we have to empathize the vote machine booth part. Here comes quick setup and visual output and protected inputs. Because while starting any project, we have to empathize first, because empathy is a very important thing in a project and machinery objects. First of all, we have to check whether the users' requirement and the challenges. By collecting all the information from the users, we have to go on with the empathy part.
So next comes the define part. So define part has certain goals, which means we convert the user's needs into a problem statement and into some specific engineering specifications.
So need to define the solution for the problem.
Then next, we directly convert the problem statement into the real-time world examples. So the user, through user, we gain some activities through which we can produce the real-time circuits. First is the point to overview, through which we gain the problem statement from the user. For example, the factory operators need to know the defected signals without manually checking the devices. So it is a problem statement. So next is the input and output of the devices. So next, the third one is the we set some specific conditions, which means the circuit need to work at a certain speed or at a certain power consumption, and at specific conditions.
Users must have these all ideas. Well,
Some ideas they need to have to through which we can design a circuit for them.
So I'm going to be talking about the ideate part. Ideate part is nothing but bringing out the best solution for our problem. So according to our problem, first we are going to be talking about the logic gate. So instead of doing it in an indirect way, we can just implement directly. Like if you are taking AND gate or NOR gate, we can just implement directly into the circuit. By using the truth table, we can just build the circuit step by step.
So circuit having general, the way you said that is basically the logic.
Yes. So with that, that would be a good solution. And next up, we can use the standard ICs. Instead of doing it in an indirect way, we can use encoder IC like 74HC148 ICs. So it does everything all together. Instead of using multiple gates, instead of wiring multiple gates, we can use this IC. And the next thing would be
See, the IC itself, we are having a lot of gates in that, so that we can use more number of applications.
Yes. So altogether, we can just use all these solutions and we can get the best solution. So this would be the ideate part.
So I'm going to talk about the fourth stage of the design thinking, that is the prototype. So in this stage, we have to build the working version of the project. So in this stage, we have to first of all build the cartograph map truth table, and then design a circuit.
So
Either
basically,
physically,
we can able to get the large diagrams so that we can build the prototyping process.
so we can build either physical or in digital way, like multisym, proteins, or logism. For example, if we build a sum segment display, so we have to take a microcontroller like 7447 or a big microcontroller. So if we want the output 1 or 2, if one we have to code 0x3f, or if we want to 0x.
So that the machine has to be accept the
Yes, sir.
condition code.
Yes, sir. So we have to put an code. So then only that give output.
So based on this, we can able to simulate the process. Yes.
And when we break down the feedback, actually testing mapping, but taking our product to the customer. By using our product, let me take the feedback. After will be give a good one. So the goal to validate the system application, select requirements, and refine the design systems. And that activities include to check the correctness or if even satisfy the uses and combinations like finding the correct output, etc. So, for example, if I'm taking a digital comparator, giving many kind of inputs and getting the output that shows correctly equality or greater than or lesser
So
than.
need to get some feedback from the customers so that we are going to give a lot of applications for the use. Yes. So we have concluded that we have discussed about how these pi stages will be implemented for combination logic circuits. Especially these combination circuits has been used for a lot of application, especially for Intel processor and Qualcomm processor. They are using combination circuits for making their logic expressions. So it will be very useful while having a lot of combination circuits in the future. Thank you.
Thank you.